We're going to finish up locus first today. There will be the last exercise in that chapter, chapter 11, that you will not be able to do yet because we need to do calculus first. So we're going up to and including 11.6 as part of the requirements you get completed. So we're up to the last one, remember? Number 4, so today's date, 20th. Nathan's 4 months old today. So that's pretty, feels like an achievement there. Alright, number 4, y take away k, all squared is equal to negative 4a, x take away h. So, focus on this now. So, that's the last one. Alright, so let's do a quick recap. Number 1 was x take away h, squared equals 4a, y take away k. Right, and that was your standard concave up parabola with the vertex at h, k. Number 2, x take away h, or squared, is equal to negative 4a, y take away k. Right, and that was your, somewhere, concave down parabola at h, with the vertex, at h, k. Right, third one was y take away k, all squared, is equal to 4a x take away h. Keep your h's with x and your y's with k's, alright? Don't do it the other way around. Don't write y take away h. You'll just get more and more confused, alright? Keep your x's with h, so your h's with x and your k's with y. So in the alphabet, h comes before k and x comes before y, so put them together. Alright, now when we have a parabola of that orientation, alright, we have a sideways one, centre h, k. Alright, so all the formulas are very different except for the little nitty gritty stuff. So y take away k, so what we're doing today, equal negative 4a x take away h. Alright, so that's the last one. Yep, so just redone the first one. I'm just doing a quick recap. Alright, so h and k tells you the coordinates of the vertex, and the orientation itself will tell you which direction the parabola opened and where the directrix and the focus lies. Okay, so whatever is squared, so x's are squared in the first two equations, is your standard concave up, concave down parabola, like your y equals x squared. Okay. So x squared, y equals x squared is how you normally use your parabolas. Okay, so this term will be the squared term if you were to go ahead and expand it. Alright, and that will be there. And of course, that is not at the origin. Okay, so it'll be plus some constant somewhere. Alright, so x take away h all squared. So if you like your y equals negative x squared, so when you've got the negative, it means you're going to be opening up in the negative direction. Okay, so when we have our concave down parabola, opening up in the negative y direction. Right, so y take away k all squared. This is like your parabola, x equals y squared. Alright, so whatever the y squared term is squared, that means it's opening out on the positive x-axis. Alright, and today, with the diagram, or in your notes, right, so we've got some centre, h, k. We've got a parabola opening out in the negative x direction, the vertex. Alright, remembering the focus always lies inside the parabola, okay, at a distance of the focal length with the variable a, which comes from the formulas there. Alright, and then some directrix which crosses the x-axis. Very poorly drawn from my standards. Alright. Very. Alright, and we have the focal length as well as the vertex to the parabola. So remembering the parabola is defined as an equidistant from a point to a fixed line. And that's what defines the path of the parabola. Alright, so all that information is in your notes. Right, let's do the last 3 examples that we're going to get this part of the topic. J. Alright, so we need to find the equation of the parabola with focus at 5, 3 and directrix at x equals 12. Equation of the parabola. Okay, so from the location of the focus and the directrix, we have enough information there to at least know the orientation of our parabola, and then from that we need to find the value of the focal length and the coordinate of the vertex. So, this is a very diagram-based topic, so we will draw on. Right, so the focus at 5, 3, so roughly about there. Okay, I'm going to have to make this one longer. Alright, directrix equation, x equals 12. So when you have x equals or y equals, that tells you which axis it cut and what point at that axis it will cut. Okay, so cuts the x-axis at 12. That's your directrix. Okay, that is the focus. So the focus lies inside the parabola, and the parabola itself never crosses the directrix. So we have a parabola of this format there. Alright, so we're at 5, 3. We need to find the centre, h, k, and we also need to find the focal length. So we can substitute it into this equation here. Right, so the first point you need to do after you join the diagram is recall the correct formula. Okay, so a parabola of that orientation has that equation. So now we need to determine some of these variables. Again, remembering the focal length is also the distance from the vertex to the directrix. Okay, so how long is it from here to here in terms of A? 2A. And how long is it from here to here in terms of the variable, of the numbers, sorry? Okay, so we've got an x value of 5 and an x value of 12. Alright. So the x value from here to here is 5. Okay, from here to here is 12. Alright, so only 12 because they're on the same side of the axis. That's where we do the subtraction. So 2a is 7, a is 7 on 2. I'd leave it improper because it'll help with the maths coming up. Okay, so the vertex at h, k. So the focus is to the left of the vertex, so we need to add the focal length to the x value. Alright, the h is going to be 5 plus 7 on 2. 17 on 2, so 8.5. And remember the axis is the axis of symmetry, so where I was going to fold the parabola and get the same thing happening on both sides, okay, is this dotted line there. Okay, that's the symmetry where it's the same on either side. So the y value, 3 up here, is going to be exactly the same. Right? So k itself is also 3. Right, so we now have A, we have H, we have K, we can now substitute into the formula. So Y, take away K, which is 3. Okay, do not put 8.5. equal to 4 lots of 7 on 2, x take away h. And that should be squared up there. So 14 x take away. Okay, so our 4 standard parabolas at where the vertex is at the origin is accessible. Okay, these orientations are not accessible in your exam next couple of days. However, remember your yearly exam is going to cover everything in your prelim course, and it's going to have much more focus on everything after your task the next couple of days. And a fair chunk of it is new work. Right, any questions with the approach or anything you didn't understand? Right, okay. For the parabola, y plus 1 all squared equals negative 24 x plus 2. Okay, so they're giving you the equation now, and you're sort of going backwards from this, alright? So they're asking you for a few things. Alright, so part I, we asked for the focal length. So what variable gives us the focal length? A. So you need to be able to look at that equation and at least tell me how the parabola lies on your number plane. Alright, so the y squared is the y is the term that is squared, so it's going to be opening out to the side. Alright, and then the negative 24 tells me that opens in the negative x-axis. Alright, so let's write the equation underneath. Yep. So that's the equation for parabola of that orientation. Alright, so we need the focal length, so we need to match up negative 4a and negative 24. Solve for a. Okay, so we now need the vertex, and we need the focus. Right, so the vertex of all our parabolas, with the centre not the origin, is h, k. So what is the coordinate of the vertex reading from your equation? Good. Okay, so there, note the plus sign, and the formula has negative. When the sign's opposite, you need to switch your signs around. Make sure you have them in the correct order. If you write -1, -2, you are not correct, and it will not be marked as correct. Right, now the focus. So I suggested this point would be a good point where you're sketching. Now that you've got a centre, so -2, -1. The vertex, we know that opens out this way. Alright, from the equation. That means the focus lies inside the parabola at a focal length, which is our A, which is what we've already worked out. That means on the other side is the directrix, and that is also the focal length from the vertex. Right, so also thinking about your symmetry, your axis there. That means the focus and the vertex is going to lie on the same horizontal plane, or in other words, the same y value. Right, so that doesn't change. What does change is the value for x, where it lies. You've got minus 2, you need to go to the left, the focal length of 6. You've got minus 2, take away 6. Alright, so part 3, directrix and axis. Yep.
Is that free? No.
He'll be in 6.2.
It says 6.5.
It'll be 6.5. Should be telling that he's going to be on YouTube.
Yeah. He didn't even know.
Good.
That's the basic thing of...
I know. Do you imagine the amount of stuff that I put up with the junior years? Some years included back then.
Yeah, you did put up with us.
Oh, yeah.
Yeah, I've taught most of you already for a couple of years. Anyway.
I'm sorry.
Alright, so directrix. Alright, is the line here, which is the focal length from the vertex over. Which axis does it cross? The x-axis, that starts your equation, x equals. And what is the value for x? So you've got the x value here plus the focal length. So minus 2 plus 6. So it crosses the x-axis at 4. Okay, diagrams are very useful. It helps you orientate things, helps you to see things. Don't try and do these without a diagram. And the axis is that imaginary line, the imaginary line there. Okay, what is the, so which axis does the axis cross? The y, when we talk about the axis, we mean the axis of symmetry. What value for y does it cross? -1, because the vertex and the focus is -1. So it's also your equation of your axis. Right. Any questions on that? So we have repeated these questions for all 4 orientation. Okay, so yes, you need to know the orientation. You need to be able to look at an equation and start picking out the differences, and then also including your sketches to get the rest of your information. Alright, coordinate the vertex and focus and the equation of directrix to the parabola with equation y squared take away 10y plus 6x take away 17 is 0. That is an equation of a parabola. Alright, just in extended form, not factored form. Right, one other thing that you should be able to look at and get information about is which variable is squared, and it should tell you from that what the orientation at least of the parabola will be. Okay, the y squared is the y variable is the variable that is squared. So if they have a y squared, it means opening up to the side. Alright, that's your first hint. So we need to get this into the form y take away k all squared, which equals 4a x take away h. Alright, I don't know whether there's going to be a minus or a positive yet. Alright, that's how you need to treat it. So yes, we're working underneath this heading, and I'm going to expect it to be a minus here. However, I've just got it in format, and if it works out to be a minus, that will tell me the direction that it opens. Okay? So, we need to be able to first complete the square, and then factorise everything else onto the other side. So y squared take away 10y. We need to complete the square on that. So I'm going to leave a space and move the other two terms onto the other side of the equal sign because I need everything else over to there on the formula. So negative 6x plus 17. Right, to complete the square, first things first, it is always positive, that third term. To get the variable, we need to halve, then square of that term there. Alright, I'm going to write it as 5 squared. When I write it like this, it's going to be much quicker for me to factorise in terms of not having to think about an extra step. Now, I've included that to the left-hand side of the equal side. To balance everything out, I need to also include it onto the right side. So, I write that without the square, add to factored, because you need two numbers multiplied to give positive 25, same two numbers add to give negative 10. Alright, so negative 5, negative 5, when we have the same number, we write it, we factor it again, and becomes a square. Equals minus 6x, so we've got 25 plus 17. Right, just about done. So note in the formula, the x has a coefficient of 1. Right, here we have the coefficient of 6, negative 6, sorry. So to get the coefficient of 1, I need to factorise that negative 6 out. So I'm left with an x. I've already factorised the negative out. So when I take a negative out of a positive, I am left with a negative, because the negative times the negative gives me a positive if I were to expand. And then we have 42 divided by 6. In other words, 6 times 7 gives 42. Alright, so now we've got it in this form from the formula, we can now get the information that we need. So we need vertex. What variables gives us the vertex? H, comma, k from the formula, in that order. Right, so h is, so negative h, negative 7, so h is 7. And negative k, negative 5. Alright, that means we do not need to include any negatives here. It's already done in the formula. According to the vertex, now the focus and the equation of the directrix. So when they're asking you to find the coordinates of the focus and the directrix, I suggest you do a quick sketch, just so you can locate everything in its correct spot. So, vertex at 7, 5, somewhere up here. Now, the y is the squared term. Alright, so I know that it's going to open out on the sides. Alright, and because the negative 6 out here, alright, it's opening out in the negative direction. Okay, so all your exercises are based on the same orientation of the parabola, like I've done with these heading. Okay, so what you need to be able to do is from that, if I were to put out a random question from all of these questions we've done for this section and for the other 3 previously, you need to be able to tell me the correct orientation and then go from that with the rest of the information. Right, the focus is inside. And the directrix is outside. Parabola never crosses the directrix. Alright, so we have 7, 5 for coordinates of the vertex that we've already worked out. Alright, and then we've got that distance A, also that distance A there for the rest of our information. Right. So, before we can write down the coordinates of the focus, we need to first work out the what? The focal length. Alright. So this is where you match your information from your diagram. So -6, so we write -4a as part of the formula. Okay, so -4a equals -6. Solve for a. Right, simplified fraction, of course, always, unless told otherwise. Alright, so there's the x value change or the y value change for the focus from the vertex. The x value change, that means the y value will stay the same. So we've got 7 take away 3/2, or 7 take away 1.5. Okay, so 5.5. Or you can write it as 11 on 2, or you can write it as 5.5. Right, doesn't matter. Right, unless you're told specifically to, does not matter. Alright, directrix. Does it cross the x or the y axis? X, that's the subject of your equation. What is the value that it crosses? Okay, vertex to the right, the focal length, it gives you the directrix. Alright, so x equals 8.5 or 8.5, or you can write it 17/2 if you wish. Okay, question. Right, so that's that covered. There is one more section in regards to tangents and normals. We have to do calculus first so that you can do that work, and we'll be touching back on that once we've done calculus. So you have the rest of today's lesson, so you've got about 20 minutes. You will have tomorrow morning's lesson, period 1 I'm pretty sure. Alright, for you guys to do some revision, ask questions, ready for your assessment. Okay, remember it's the second half of geometry that we did at the start of this term. It is trig, and it is locus up to all examples where the vertex was at the origin. Okay, I'm pretty sure that was it. Keep getting this funny feeling that there's one more topic, but you all have your notification sheets
Do you have
to be able to do that. Also on the Thursday, you all need to bring your exercise books in. Okay, I'll be checking them off on Thursday. All right, see what work you're up to. Okay, and have a conversation with you in regards to your work. Okay, so I've given everyone a bit slightly extended because of extension because I've forgotten about your assessment. Okay, don't forget math, extension 1 students, you will have your extension 1 assessment on Wednesday. It will be during assembly time and lunchtime. There will be no formal class on Wednesday morning, however you are more than welcome to come in and I'll be here if you want to do some extension revision ready for your assessment. Right.